Okay, let's discuss the idea of dual norms in this lecture. So dual norms is basically the norms which we can derive from an existing norm or a pre-norm. Okay, let's first look at the definition of a dual norm. Definition. Let F be pre-norm. So by pre-norm, we mean that it satisfies non-negativity, positivity, and homogeneity, not triangular inequality. Not necessarily triangular inequality on Rn. Could be in any vector space, but let's take Rn. Then the function fd of y. So how do we find the dual norm? Is by solving an optimization problem. This max of f of x is equal to 1 y transpose x. This function is called the dual norm of f of x. So one thing to notice here is that the function need not be a norm. It can, even if it's a pre-norm, we can find a dual norm using this. And this dual norm is actually a full norm. In the sense, it also satisfies ranked inequality. There's an alternate version of this dual norm, which we can write. So also note that what does this mean? This means that we take all the set of points which satisfies f of x is equal to 1. For example, the cases which we took for L2 norm is equal to 1 is the locus forms a circle, right, of unit radius. Similarly, take all those points and compute y transpose x, and the maximum value of that will give you the norm, dual norm of that function. So there's also an few alternate formulations. So f of minus x, we know, is using homogeneity principle is same as f of modulus of minus 1 and f of x, is same as f of x. So even though f of x is equal to 1, there can be also cases where we can take all the cases where which include f of minus x as well. Okay. So those cases are also involved. It need not be all the cases where. So if you have x, a set of x's which gives f of x is equal to 1, all the minus x's will also give f of x is equal to 1. So fd of y can be even more broadly specified as max of f of x is equal to 1. It's not just f of x. It is modulus of y transpose x, because even the minus x values will give you the same f of x is equal to 1. This is another way of specifying dual norms, which is useful at proving triangle inequality and all those things, right? And yeah. So let's try to prove this, prove that this dual norm is a norm. Prove fd of y is a norm. The first thing to prove is non-negativity. So let's not consider the trivial case. Let's say y is not equal to 0, then fd of y is equal to max of f(x) is equal to 1 modulus of y transpose x, right? Now, let's take one of the cases here. If we have y by f of y satisfies this condition. If you put this function y by f of y, this is 1 by f of y into f of y, which is equal to 1. So this is one of the cases of x which satisfies this condition, right? So y by f of y is a normalized form of a vector. This vector satisfies this condition. So we can actually, this is max of many such x's. So this will be definitely greater than or equal to max of uh, greater than equal, not the max. This will be greater than equal to the case where we have taken f of x is equal to y by f of I. So this is y transpose. X is y by f of I. Right? What is y transpose y? This is the L2 norm squared divided by f of y. We know that since it's a standard norm, this is greater than or equal to 0. So the lower bound is greater than or equal to 0 implies fd of y should be greater than or equal to 0. Now let's look at 1a. Let's put fd of 0. That is equal to, if you take in the case where y is not equal to 0, now let's take the case where y is equal to 0. This is equal to max of x is equal to 1, 0 transpose x. This is max of all zeros, which is in turn 0. So it satisfies a positivity condition. This is a trivial case where it is equal to 0. And we've shown that for any other case, this is greater than or equal to 0. So 1 and 1 are satisfied. Now let's look at the homogeneity property. Where we have to find fd of cy. Right? Fd of cy is max f of x is equal to 0 modulus of y cy transpose x. So c is actually a scalar. The c and c transpose doesn't matter. This max of f of x is equal to 0 c modulus of c into y transpose x. So max of a constant into a function, you can take the constant outside, the positive constant outside. So this is max f of x is equal to, sorry, it's not f of x equal to 0, it's f of x is equal to 1. Y transpose x, which is 3 times fd of. So this satisfies homogeneity property also. Now let's look at triangular inequality. Triangular inequality, we have to prove that fd of x plus y is less than or equal to fd of x plus fd of y. This is what we have to prove, right, for triangular inequality. So note that f of x is actually a prenorm, which does not satisfy triangular inequality. Anyways, let's move further. Fd of x plus y is the max of f of x is equal to 1 y transpose. Let's say there's no y here. Let's take z transpose. Z transpose Yeah, interestingly, mm, let's take the case where, okay, let's put, I think the better way is to put uh, y plus d, because we already have f of x here. Set of all x's such that, yeah, this will be more accurate way of describing it. X plus y whole transpose into x. Transpose is actually distributive. You can actually distribute it over the sum. The max f of x is equal to 1 modulus of y transpose x plus um, z transpose x. So this is what we've got. Then can we split this max term? So this is uh, max of two numbers, but max of sum of two numbers. But this can be negative, positive. Okay, x transpose y can be positive or negative. So if you take the max of this two separately, this will be less than the max of their sum. So this is less than or equal to max of f of x is equal to 1 y transpose x plus max of f of x is equal to 1 z transpose x. So this is equal to ft of y plus ft of z. So this also satisfies triangle inequality. So this in this way we can show that the dual norm of a pre-norm is a valid norm. It's a full norm. Okay, let's end this discussion.